ماذا 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 لو أن الكفاءات الجزائرية من كافة أنحاء العالم تجتمع معا؟ ماذا لو أن هذه الأدمغة بمختلف تخصصاتها تتكاثف لتطوير التعليم والبحث العلمي للنهوض بالجزائر في مختلف المجالات؟ هل تعتقد أن هذا مستحيل؟ أبداً، فالحلم يتحول إلى حقيقة من خلال الشبكة العالمية للعلماء الجزائريين إيناس. رغم أن إيناس هي مؤسسة غير ربحية وتعتمد فقط على تبرعات الأفراد، إلا أنها استطاعت أن تبني جسوراً من التعاون وتبادل الخبرات بين أبناء وطننا الحبيب من الداخل ومن مختلف بلدان العالم، ساعية لصقل المهارات واحتواء المواهب وتبادل الخبرات وإيصال التجارب النافعة لخدمة الوطن.
Salam alaikum, wa masal khair alaikum. Marhaba bikoum معنا dans une nouvelle série de webinaires avec INAS, l'International Network of Algerian Scientists. It has been a long time no see. Ça fait longtemps qu'on n'a pas fait ce genre d'événement en ligne et maintenant on espère revenir en force, j'espère, avec un nouveau projet, Application of Artificial Intelligence in Geosciences. My name is Mohamed Amrouche. I will be co-hosting this event and today we have with us Imad Laouici. Salam alaikum Imad.
Salam Hicham, salam Mohamed, salam everyone.
Merci de nous d'avoir accepté ce projet. En fait, le projet il est co-hosté par Imad et on va essayer de commencer une nouvelle plateforme ou bien une nouvelle web series où on va essayer de exclusivement parler des applications de l'intelligence artificielle dans les domaines des géosciences. Donc, without further ado, we're going to play a short video. On va essayer de passer une petite vidéo, introduction de ce projet. Et ensuite, je vais laisser le microphone à Imad qui va essayer d'introduire encore plus ce projet.
تزخر الجزائر بتنوع مواردها الجيولوجية الطبيعية من جهة، وبمواردها البشرية الهائلة والمتمثلة في الطاقات الشبابية من جهة أخرى، مما يؤهلها لأن تواكب عصر الذكاء الاصطناعي في ميدان علوم الأرض. يهدف هذا المشروع المندرج تحت مظلة الشبكة العالمية للعلماء الجزائريين إيناس إلى جمع الباحثين في كل من مجالي علوم الأرض وتقنيات الذكاء الاصطناعي من أجل العمل على تطبيقات ذكية. كما يسعى المشروع إلى تطوير شبكة تواصل وتعاون مثمر بين الجامعات والشركات النشطة في الجزائر. لا شك أن تقنيات الذكاء الاصطناعي تقف وراء تقدم مذهل في مجالات متعددة كالطب والبيولوجيا. يضع مشروعنا هذه التقنيات الفعالة في خدمة علوم الأرض، بدءاً من مراقبة الظواهر الجيولوجية بواسطة رؤية الحاسوب Computer Vision إلى إدارة البيانات الضخمة Big Data Management وتحويلها إلى معلومات قيمة باستخدام تقنيات التعلم العميق Deep Learning والاستنتاج الذكي Intelligent Inversion، حيث أن الجمع بين هذين التخصصين يفتح آفاقاً جديدة للبحوث والتطبيقات. وبينما تعتبر علوم الأرض محركاً للتطور الاقتصادي والاجتماعي، سوف يمكننا استخدام تقنيات تنبؤية دقيقة من استثمار مواردنا الجيولوجية بكفاءة. انضموا إلينا في رحلة استثنائية تجمع بين علوم الأرض وذكاء التكنولوجيا. دعونا نشارك في بناء مستقبل أكثر استدامة، حيث يلتقي العلم والتقنية لخدمة مجتمعنا وبيئتنا.
Voilà, donc après la petite vidéo, je vais laisser le microphone à Imad. The floor is yours, Imad.
Thank you, Mohamed, very much. Salam alaikum. Hello, everyone. Just small technicalities. I have to ask Hicham every time to pass slides, so sorry for that, but I'll try to make it fluid. So again, hello, everyone, and hello for this first webinar in this series of webinars about application of AI in geosciences. So delighted to be your host today. So I'm Imad Laouici, and before going into details, I'll try to shed light on my background and my profile. So please, Hicham, the next slide. So I do come from Algeria. I started my journey in the University of Qassim Arbah in Ouargla and the Institute of Hydrocarbon and Renewable Energies. Then my path took me to Russia for a couple of years, where I spent 2 enriching years in the petroleum engineering and geological engineering in Kazan. Then I moved to France, where I completed my study, and I have the privilege to join the Belgium since 2 years, and I work as an early stage researcher. So since my first student days, I have been always interested in numerical geosciences and numerical applications, and this fascination still drive my current research endeavors. So before going into details, I'll first speak about in some generalities about AI and geosciences. Then I will delve into this project details and what we expect from this myself, and what we expect this with Ines from this project. And then I will speak a little bit and give a glimpse into my own research work. So without waiting longer, I will start by something you may all know. So what is AI? Basically, in 2 words, so AI is the theory and development of computer systems that are able to perform tasks normally requiring human intelligence. And of course, we can find 3 types of AI. First, the artificial intelligence narrow or weak AI, which is the AI that we encounter in our daily lives. It is the power behind the recommendation systems and vocal assistants, etc. And it is basically an AI that is very powerful for one specific domains, but it lacks the capability that we associate with the human intelligence. Next, we find the general AI, which is more powerful but still theoretical for now, which is the AI that try to encompass different domains and try to mimic the human cognitive abilities. But still now it is only an ambitious goal. And finally, we find super intelligence AI, which is only a theory, like we find in science fiction movies, which is the AI that surpass human intelligence and over all domains, and could lead to unprecedented challenges and changes. But again, it is only a theory for now. Sorry, I have to show this before. So now I will speak about different branches that we do have in AI. And of course, there is different structures and different way of showing things. I do prefer this picture here because it shows the most important branches in AI. So we have in the forefront machine learning as the most used AI types. We have also knowledge representation, which is very important branch of artificial intelligence. We have also natural language processing, robotics, and computer visions. For example, machine learning, it is the power behind systems that are that learn patterns from data, and it is the driving force behind the systems like predictive modeling and also algorithms that have the ability to improve over time. We have also the branch of knowledge representation, which is very important in a way that it is specialized in encoding information in a way that a human can, or a human also and the machine can understand this type of information. This could be very useful when we try to mimic or build systems that mimics human cognitive processes. You have also a computer vision, which is very important because it tries to make decisions based on visual data. And also we have natural language processing that do the same thing, but based on human language. We have examples like chatbots and vocal assistant that do the same thing based on natural language processing. Of course, all these AI are overlapping, and a single or given algorithm, it could be based on different types of AI. Next one, please, Hisham. So where we use this in geosciences? So the short answer is basically everywhere, and it is used now in every single domain, from very basic levels of collecting and cleaning data to now interpreting and getting complex information from data. And the applications are now exponentially increasing in the last days. We have applications, for example, in remote sensing, when AI is applied to process and analyze vast amounts of remote sensing data, including satellites and aerial imagery, to extract valuable information about the Earth's surface and also the atmosphere. Algorithms used here are basically machine learning algorithms like convolutional neural networks, that are used to image classification, object detection, and feature extractions. You have also another type of other application of AI. When used on predictive modeling for seismic activity, here we use algorithms like machine learning, and more specifically we use support vector machines and also recurrent neural networks. We have also the expert with us today, Dr. Mohamed. Could you confirm this information or no after that, if you'd like? Of course, I will not be detailing all the aspects here of AI, because we use with them in different applications in geosciences. So we have also climate change modeling applications that use AI, hydrological modeling, geoengineering, also use massively these techniques in natural resources exploration and also exploitation. And my personal view is that the ML techniques are taking the largest portion of the application of AI. But recently, I think that experts are seeking more and more applications that give explainability that lacks in ML systems. And I will be speaking about this in a bit. Please, next one, Hisham. So, of course, like any tool or any technology, AI technologies have advantages but also disadvantages. For example, they are very efficient in automation and decision making, and also automating tasks that generally are laborious and time consuming. But there is a lot of concerns about total lack of human or limited human interaction with the systems. There is also an important aspect about ethical concerns about using AI technology, especially in interpreting and making decisions. We can also speak about job displacement or the shift. For example, if we observe actual positions that are offered, generally we ask for numerical skills in addition to the core skills. Next one, Hisham, please. Of course, when we speak about AI or any technology, we have to speak about some challenges and considerations that must be taken into account, at least to have some reliable outcomes. For example, here we speak about data quality and also the quantity of data, especially, for example, for algorithms like machine learning algorithms and that use supervised approaches. For example, they use massive amount of data to get reliable outcomes. It could be also complicated because it could take massive computational resources that could be very complicated to have for small companies or also individual users. We also speak about model interpretability that could be challenging, especially with techniques that are based on black boxes, for example, like deep learning techniques. And of course, we can speak about public perception, especially when we deal with non-expert or sometimes as expert. For example, when we deal with the human resources or project managers and try to convince them to use certain method, or also non-expert that gave the experts, sorry, that came from certain domain or that use certain method, and we try to convince them to convert to another method that is not yet familiar with them. This could be very challenging to deal with. And speaking about persons that use AI, please, Hisham, next one. There is, if I may say, two ways of using AI, especially in geosciences. There is the part where we have multidisciplinary teams, where we have data scientists and information scientists, and also geologists. Geologists here works on formulating and getting scientific questions that AI can address, and also they work on ensuring that AI models and outcomes honor the geological principles. While information scientists here work on implementing and developing the methods tailored to the scientific questions and also the geoscientific data sets, which could be very important. The other way of using AI is also having versatile geologists that can specialize in one generally in one application of AI. For example, I belong to this category of people. Also, we could have data scientists and information scientists that have accumulated geological knowledge, and then they try to apply it on the different applications. Next one. So what we want to do in this program, and the main goal is basically enhancing the synergy between the different users of AI. Either they are professionals, academics, experts, or young researchers, and also students. And my personal view is that such dynamics will help in the exposure. Could you pass the next one? The exposure of young researchers to cutting edge technologies in order to be familiarized with the latest advancement of AI to foster forward-thinking mindset and prepare participants to technological landscape that they could find in their professional pursuits. Also, please the next one. The interaction with different speakers will help in having a multidisciplinary learning and getting access to different perspectives that could enrich participant understanding of AI and its application, and also improving innovative thinking. And finally, Hisham, also it allows mostly young researchers and also students to interact with different experts, and this will help them to apply their theoretical knowledge by seeing how AI technologies and methods are implemented in real life scenarios. So I think if we can, sorry, oh, no problem, we can leave this. Sorry, no, we can leave it. So I think if we can make this program work, of course, together, it have an immense value and virtue on the Algerian scientific community and also on the international level. So what we want to do is basically we want to have two types of activities. First one is by giving a series of webinars. Each time we try to invite a speaker, could be on the global or also from local experts. We try to have a frequency of one webinar per quarter or trimester, and of course we can increase the frequency if needed. And of course it will be on the different topics that we just seen earlier. By the way, the next speaker, please, Hisham. Next speaker, of course, will be Dr. Mohamed Amrouche, who co-hosts this session here, and he comes from SLB and will be speaking about machine learning applications in his company. So please stay tuned and come in. And the second way of second activity that we want to offer is basically an online or virtual workspace where we want to encourage collaborative work between mostly student and young researchers. For example, we want or we encourage them to share their, for example, scripts, code, and developing them, of course, under the supervision of experts. And also we want to guide them to have open source or to use open source data and the materials for during their work. Of course, because this program is brand new, any feedback on how we can optimize things also are the most welcomed. So I think I will let Hisham here show the workspace and how it works, and then I'll go back to speak about my research work actually. Please, Hisham, إليك الخط.
السلام عليكم. راكم تسمعوا فيا؟
Yes, Hisham.
Loud and clear, Hisham.
اوكي. اهلا وسهلا بكم مره اخرى. شكرا استاذ عماد. استاذ عمروش كذلك شكرا جزيلا على الجهود التي تقومون بها. هذا الموقع الداخلي تاع إيناس. This is an internal website, and we do also have a workplace which is a Facebook, professional Facebook for companies or organizations. نبدأ بالworkplace. أي عضو في إيناس عنده لاكسي للworkplace وكان different groups, academic writing, marketing, في IT, في different areas, data science, new groups, upcoming new groups. فنروحوا directement Geoscience. فالميزة فيه any member can join this group, can chat, can rooms, you can share files. It's like Facebook. You can have rooms, meetings, invite your friends, and you can have all types of collaborative work. أما بالنسبة للموقع الداخلي you have all the past activities. فهنا مثلا نشوفوا في Geoscience كان 3 main projects sub projects في geoscience, the all project تاع hazard mitigation. All the videos are here. You can add your suggestions, ideas, how to develop these videos. We can come out with articles. يعني مجموعة من الطلبة ممكن يخرجوا بمقالات علمية من كل فيديو تحت إشراف أساتذة في الجيوساينس وتخصصات أخرى، ماشي ضروري فقط في الجيوساينس، ممكن يكون بالتعاون مع فريق الاي تي. فذاتس a good thing. هذا الدومين الثاني في الطاقات المتجددة، مشاريع كلكم شاهدتوها من قبل. والاي اي ان جيوساينس which is the new project، فتلقاو الوصف تاع البروجكت، الاوبجكتيفز، شورت فيديوز. الفيديو تاع اليوم حيكون لهنا ثاني. كاين نوت بوك، كالندر، conversation documents، يعني كل ما تحتاجوه للعمل الجماعي ممكن تجدوه هنا في هذا الموقع الداخلي. مثلا articles of past events، كامل ما تم من إنجازه وما سيتم إنجازه إن شاء الله تجدونه هنا. فموقع إيناس www.inasnetwork.org. You just click on members, join us, become a member. You can fill up this form وسنرسل لكم القبول مع إيميل إيناس، بروفيشنال إيميل والباسورد، وبعدها ممكن تدخلوا في الورك بليس والانترنال ويب سايتس. هذا ما عندي أستاذ عماد.
يعطيك الصحة هشام، شكرا. Thank you very much and I'll resume.
الو تسمع فيها هشام؟
نسمع. You can remove me. أنا درت
Yeah, I think we lost Imad. I don't know if you can hear us. It seems we have some technical difficulty here.
عماد. عماد هل تسمعونا؟ Okay.
Sorry.
Yeah, we
I
got
lost
him back.
1 minute.
Okay.
Sorry.
Okay,
Cutting in
go
power.
ahead. Sure.
So I'll go back now to speak about my research work actually in the Belgium. So as I said, I work in the French Geological Survey as the early stage researcher, and I work actually on subject that involves knowledge representation and reasoning. So the actual work is basically you can show this again, Hisham. The actual work is basically about to produce or to present a geocognitive approach to build 3D geological models based on automatic interpretation and formal experts knowledge. So as I said, we use knowledge representation type of AI, and as I said, this type is about formulating and making numerical content understandable for computers and systems, and this to mimic the human cognitive processes, especially, for example, to make interpretation or to make reasoning. And what I do is basically to apply this kind of AI on the process of building 3D geological models. So what are 3D geological models? So for non-experts, please Sam, show the next one. So 3D models or 3D geological models are structural geological models are three-dimensional numerical representation of the subsurface structures and arrangement of rocks layers. And to build a model, basically we have a very long chain of operation, but we can reduce this in these two main processes. You can show the next one, Hisham. So we have initially inputs, and then we have the process of analyzing them, and making decision, and basically making interpretation about the inputs. And then we try to numerically represent what we have made. We have made like a model in our heads. So this is basically the actual paradigm of building 3D geological models. So to give you a small example of that, please Hisham, show the next one. So for example, we have two boreholes here, and we see two markers in red here that correspond to some stratigraphic surface. And with actual algorithms or tools, they offer only an interpolation based solution. So any tool will give you this kind of representation. Can you show the next one, Hisham? So this kind of calculation is basically calculating between the two known location and try to get the values between in non-known regions or areas. Of course, we can use different methods here, but the most important that no, before this one, Hisham, but the most important here that we cannot, if even if we know that there is a fault here or any type of structure, the algorithm is not capable of doing so unless we instruct this. So the solution generally what we do now, the next one, Hisham, what we do is basically try to add some interpretive constraints like another borehole, and sometimes even draw, if we suppose that there is a fault here that we can see in red, that there is fault that pass here, and draw this manually. So this is actually the solution for making this interpretation and forcing the algorithm to understand this. Another example, show the next question, please, is this situation when you have, for example, three boreholes and we have red markers, and we make some interpolation here, and we get something like this. So the stratigraphic surface here is basically deformed, and for geologists, this is very intuitive, and we can understand directly there is some fold in here. But for an algorithm, this is impossible, and algorithms do not detect that there is some fold here. There is only a stratigraphic surface. And of course, there is numerous work that try to surpass this and give some solutions, but basically we are still in what we call an interpretation-based human paradigm. The next one, Hisham. So this paradigm is very practical, but it comes with different limitations. For example, there is no way to perform automatic interpretation and use explicit knowledge away from the interpolation-based framework. Also, we are not dealing directly with the geological features and concepts, but only about with their mathematical and representation. Sorry, their mathematical representation. Um, and maybe one of the most important challenges is basically the, the the limited interaction with the introduced knowledge. For example, when certain information we try to force it in the algorithm, we cannot do so because generally the algorithm is in the back end of the tool or the numerical environment that we use, and we are forced to make some interpretive constraint or introduce some cross sections, for example. This is during building the model, but also after building a model, we have other limitations. For example, the results are 100% depending on experts and the expert that made them, and which is very uh, um, could be affected by some cognitive biases. For example, somewhere the interpreter will stick to his own interpretation and try always to justify it. Another another limitation is the complexity to, or maybe possible to exchange models. We could exchange only the representation in a numerical format, and this could be also very challenging to reproduce a model. And basically, we cannot do so. Even if the same model try to take the same path, it is sometimes very hard to reproduce the same model. And of course, we are not taking advantage of the machine capabilities, especially of calculation, precision, and most importantly, repetition. For example, a geologist or some expert, he will try to interpret a seismic profile of 1 kilometer. It will be very easy. 2 kilometers easy, but if we give him 300 or 400 kilometers, sometimes he will get tired or also bored sometimes. But a machine, it does not have such feeling, and it will be doing the same thing and repeating every time without any complaints. So basically, Hisham, please. The main issue, we are identifying two main nodes, if I may say: the interpretation process itself, because machines do not do so, and also the use of experts' knowledge and how we use it. And of course, these two things are interconnected. Next one, Hisham. So basically, what you propose is a geocognitive approach to build geological models based on automatic interpretation and formal expert knowledge. What this approach is not offering, of course, we are not trying to replace experts that make models. We are not proposing any correct geological model, because there is no such thing. And also, we are not proposing sealed black black box, sorry, self-made model that will not tell you what it made a certain decision. This is mainly speaking about ML, machine learning models that cannot justify why it makes certain interpretation or not. Sorry. Next one, Hisham, please. So what this approach is about is basically about finding common ground between interpreters or experts and also machines to make automatic interpretation of the inputs. It also put the direct interest in geological features and not their mathematical representations, which will offer some easier way to deal with different scales or resolution during the interpretations. And also, by this way, you are facilitating the interaction with the introduced knowledge. And most importantly, when we made a model based on these steps, it will be easier to share this model with other experts, because we are storing every decision and every step that we have taken to make a certain model. And of course, this is an original way to explore what we call epistemic uncertainties, that are attached to human cognitive biases. Next one, Hisham, please. So we have two main objectives in this work: the automation of the interpretation process, and second, the formalization of experts' knowledge. And of course, to do so, we have numerous scientific questions that arise from these two objectives. First, how experts make interpretation, which is very important. Then, how we could make machines do the same thing. And second, what is expert knowledge, how to acquire it and use it, what other processes are used to deal with it, and how to communicate this to machine. Of course, all these things are interconnected, and we cannot speak about an interpretation without speaking about knowledge, because each one used the other one, of course. But for the sake of simplicity, we are splitting this task into this process in two tasks. So first, we'll concentrate on the interpretation formalism that we'll try to do and propose a prototype for that. Then we'll tackle the second aspect of formalizing knowledge. So as I say, machines do not interpret, which means we cannot make certain situation and tell machine or system, okay, go ahead and interpret this. This is not possible yet. And what we want to do is basically do exactly this thing. So we have to select certain situation, or making the machine able to select certain situation that is not yet explained, which means it is ambiguous for a machine, and retrieve relevant information, first defining what is the situation that the machine does not understand, then retrieving related information that could be associated to this situation. So for example, if we go back to our example here, and within this situation here, we have the two boreholes with the two markers, and the situation here, I don't understand, or I don't know what is between these two. Of course, if it could be easier if I know I am in context of faulting, but also it could be done without knowing this. So if I know this, the second thing that a human will do will try to propose an interpretation that make this clear, the situation. So the next one, Hisham. So basically, you try to propose an interpretation and oralize it. Propose an interpretation, which means proposing the theory, the concept in my mind that try to make the situation clear, and then try to realize it by giving values to its property. So if I say that I have a certain deformation here, now it is easier for me to give values to this deformation. So if I say that I have two markers that have different values for example, in terms of altitude, I will have some possibilities of having some deformation structure, but I will not have 1,001. I have only a 5, 4, or any, or very, very finite number of possible concepts that explain this. And the idea is choosing one. We don't focus here on how we chose the concept that explain the situation actually, but just select one. It could be done randomly. So Hisham, please. So I will, of course, the situation must be well described to be able to retrieve what could explain the situation. Yes, this one, Hisham. So I will make a situation here that, okay, I have some faulting. Now I will have to realize this faulting. So I will I could make this type of faulting, could also make this one. The next one, Hisham. This is a different fault, and of course we have a normal fault and an inverse fault, and I don't know which one is correct, but this is not important. Just make an interpretation. This is what a human do. He or she will make the interpretation and then try to evaluate it. So this is the next step that we want to do. Please, Hisham. The next step is evaluate what I made like an interpretation. So I will evaluate this. I can evaluate the theory that I have a fault, then I will evaluate the realization that I made. The realization is basically the evaluation is based on confronting the new interpretation with the prior knowledge that we have. So I don't have any information that could refuse or it is contradicted with this interpretation. So I can vouch or confirm this interpretation. The idea here is not getting the correct interpretation, but basically getting the not the most but plausible geological interpretation, which means it honors the geological principles, but it doesn't matter if it is correct or not, because we will never know the truth, especially in the subsurface. So the next operation in the loop, it will be acting based on the evaluation and the decision that I made about the interpretation, and then of course it will be exiting the loop and entering another loop at the next one, and so on and forth. And by this, each time we select a new feature or interpretation that we want to interpret in the domain or the range of study that we are studying. And of course, by this we build step-by-step structural model. Of course, at the beginning we have to be interested only in geometrical concept. Then we move in different levels of interpretation to more structural and even tectonic aspects. So this is basically the interpretation paradigm that we try to propose. Next one, Hisham, now. Thank you. And now this is the second aspect they want to tackle, is basically the formalization of knowledge. Of course, to make this interpretation, each situation must be well formalized and well described, which means this is the situation that I don't understand, and this is the possible explanation, this is the related information, etc. Of course, to do so, this is could be very challenging, especially with existing tools. So what we want to use, or what we are using, is basically semantic technologies. So these technologies are a set of technologies and methodologies that enable computers to understand, interpret, and process information in a way that is closer to human understanding. Of course, this definition is similar with knowledge representation class of AI types, because these AI types use these semantic technologies. So the term semantic is in the context of relates to meaning and context. And these technologies aim to enhance the understanding of data by associating explicit meaning with it. So we have different technologies. The next one, Hisham, please. We have here very basic technologies, and we move up the ladder to more complex ones. So we have at the very basic of this semantic layer cake, we have the URI, which is unique identifier for example, for a concept. So let's take an example. For here I have the concept for the next one, please, Sham. I try to do it. So I have, for example, the concept fold. I want to describe it over the internet, for example, over the web, and I will be describing this through some internet page that gives the metadata and the definition of what is a fold, etc. And of course, we'll give it some URI, which is shown here. It's look like an URL, but it's just another type of it. And then we have another technology that is based on URI, which is the RDF. Could you show the next one, please? So the RDF is basically relating three nodes. Two nodes with the relation. So we have subject, predicate, and object. The next one, Hisham. So I could, for example, this information, the fold is a geological structure. We have this in we call an RDF store, or it is basically an URI for a fold, an URI for the relation is something, and an URI again for geological structure. And each one is described over a page in the internet. And in each page, it can lead you to another page, etc. So this is the second technology that is based on URI, and then you have other technologies, of course, that are based on RDF, like querying technologies like Sparkle, RDFS, rules, etc. And as we want to use the ontology. So next one, Hisham, please. So ontologies are in the semantic web world, they are particular conceptualization of a given knowledge domain shared by a community of users, which means this is some knowledge that some people or a community of people shared, and it is described in a specific and a formal way for both for a human and also for a machine that could be shared over the web. So again, Hisham, please. So if we take another example, so I have some knowledge or about fold, and I know that a fold is something. So I could define this a fold based on the previous technology. So fold is a geological structure, and also I know that the fold have some characteristics. So I will have this kind of RDF. So saying that fold has wavelength. Also, I could say a fold have two limbs, have a structural surface, have an axial fold axis, etc. And all this grouping all these of kind of definitions or RDFs and store them in a way. This is basically the structure of an ontology. I will not get in more details, but this is the structure of the ontology. So please, next one, Hisham. And we want to do, or what we are doing now, is basically proposing this ontological model that describe geological features, how they are related to inputs, of course, how they are related to acquisition data, like well data, observation of fields, geophysical data, etc. And of course, we want to describe the characteristics of the geological features, and again, describe also the algorithm used in the interpretation process. So you have also an important part of describing the interpretation process itself, use these technologies, and then relating these processes to the geological features and what they interpret or what they depend on during this loop of the interpretation process. So this is basically the work that I'm doing now, and because we are in some early stages of the work, I will not be able to share more details, but I will be very glad to share more details when this comes to end. So I will try to do this next times. So I think I finished from my side. Thank you very much for listening. And again, please join our group and also workspace. I know this is at the beginning, but we'll try to increase the frequency and each time invite experts. And I'm very optimistic about the ongoing of this project. So I will let Dr. Mohammed speak, and also Hisham if they have some
Thank
notes.
you very much for the presentation, Imad. I recall that this is still an ongoing research project, right? So we're just having a glimpse on what's being done.
Of course, yeah.
So congratulations again, and really good job. I mean, good
Thanks,
luck
man.
for the publication. Looking for the result.
Of course, yeah.
So yeah, we remind you that this project, I would like to emphasize that we are starting a new project here, applications of artificial intelligence in geosciences. Again, we don't want this to be a one-way webinars event, whether it be a more collaborative. So as Imad showed in the slide earlier, we will have webinars. We're still discussing how we're going to have them, not monthly for sure, but at least quarterly or each 2 months. And we will invite some experts doing AI in geoscience so that he can share with the audience what is being done in AI for geosciences. And also, we parallel to these webinars, we are going to have some internal workshop or groups, or you call it whatever you want. We try to be active. We try to gather maximum number of people because this is something new. In geoscience, many geoscientists are not computer nerds, as Imad mentioned before. So it's very good to find a balance how AI can contribute to geoscience. So I think we have a few questions. I remind you that you can ask your questions and your comments in the comment sections. Let's pick up one from Amin Horseman. It's been a long time no see. Thank you very much. So first question from Amin in Facebook. Thank you for the presentation. Do you know if enough Algerian data is available for applying AI to geoscience? Oh my God. Okay, you can go for it, and then can
this is very tricky. I don't have too much experience in Algerian the data sets, so I don't have the much
Okay,
info,
maybe
but
I
I'm
have.
not sure. I try to look sometimes
I've
in
been.
some
Yeah,
data sets in the Geological Survey of Algeria, but I don't know if there is very open
yeah. I
or
think this is
available
something
data
we
sets.
have been tackling recently in my company. Is that we basically what we try to do, we try to train machine learning models using external data and try to implement them in some kind of geological configurations that looks similar to what we have. Okay, so let's say you have an extensive basin, geological basin, where you have faults systems, and we have some similar geological setting in Australia with open source data. So we can train this model in Australia and hopefully try to use it in Algeria so that we can detect the faults. I'm going to cover this a little bit in details in my presentation, but I believe that, yeah, it's still a big struggle because of the data availability in Algeria, but, we can still do things, I believe. Yeah. Go ahead, Imad.
I think I misread. Sorry, I have to go back to the previous question. I misread the. I stopped in the Algerian data and didn't continue what had been said. Sorry, this is my bad. Of course, yeah, this is very problematic, and this is not only for Algeria but also over the world, because the geological nature changes very much between, like Mohamed said, between an extensional basin or some tectonic other tectonic context. It's could be very inaccurate to choose some Algerian dataset over Tunisian dataset or French or American. So this is very problematic, and maybe this is one of the main motivations of my own work, is basically to propose knowledge representation, or basically some system that is based on very explicit knowledge that has been introduced by people, because based on only on existing available information, this could be very hard to get some model that fit all the data over the world. So it could be very complicated. There is some work that have been done to 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 train models on very global concepts, if I may say, and then have very fine-tuned models based on specific location in some geological context. Of course, this could be very confidential for oil companies or geological surveys.
Thank you for that.
Thanks, man.
Thank you very much for the questions and for the answer, Imad. I'll pick up another questions from Tarek from Facebook. Question to Imad. Many modeling algorithms such as kriging are based on variogram analysis and high-level data analysis. How AI is improving the existing modeling techniques?
It depends. Many modeling algorithms. Kriging itself is not an algorithm, but an operation that's used within an algorithm that is based on kriging. But yes, AI is more useful because it learns, if I may say. It depends on which AI you are speaking about. So if I speak, for example, about machine learning, because it learns about data and take patterns that have been not covered if you use like usual variogram analysis, and this could be very useful to use some machine learning about some general area. But also it depends on, as I said, on which AI you are speaking about. So if you use, for example, what I mentioned or presented about using some method that use knowledge representation, this could be useful because existing algorithms do not interpret from their side. They do not make interpretation. They only help you to make the model. So if you use some AI that can interpret, this is very huge step forward to use or to improve the existing modeling techniques. Mohamed,
yeah, thank you very much. Yeah, we'll pick up the questions. We have so many questions and comments. Let me try to go quickly. From Facebook, from Mohamed Bashir, very nice presentation and interesting project. Very professional, mashallah, for human knowledge integration, informed machine learning. He's sending some link you can use. Did you consider some tools from explainable AI, for example, Line?
To be honest, from my side, I didn't, but I will be very glad to look at this one.
Yeah, so we have the link, I think, right? So we can.
Okay, for integration, did you consider some?
Yeah, if you go quickly, some others from LinkedIn. Omar is asking, can someone share the link to the working group? Thank you. So maybe Hisham, the moderator, can send the link of joining Inas and joining the group in the chat box. Probably you can just follow the link, or I can see a ribbon here to join INAS network. It's inasnetwork.org/member, or maybe now Hisham is going to paste it in the chat box. I think we have some other questions. Let me just go through that. Okay, I think we have them. So yeah, I think probably we just pick one question from Tarek as well. Thank you very much for the very interesting topic. I think AI was pushed too much these last years in geoscience without really changing our daily routines. Can you give some example on how AI changed work on geosciences?
Mohamed, do you have any feedback?
Well, I can take this question. To be honest, from what I saw is usually, especially in data science, automation. When we talk about data science, how you can handle big data, when you have like gigabytes of seismic data, hundreds, thousands of wells, thousands of log duplications. Here I'm talking about people on the oil and gas industry. When you have duplication of gamma rays, of sonic, how can you manage to sort all this automatically? AI can play a significant role to do this. I see that myself. It can really handle a very large number of wells of seismic and sort them very quickly. When it comes to seismic interpretation as well, I will try to introduce something on what our company SLB Schlumberger is doing on that. We achieved an acceleration of 80% time faster seismic interpretation by automating fault extraction, as well as horizon interpretation. This is not science fiction. This is something that's already commercialized and people are already working on it and adapting it. Still, the adaptation is not very, very quick in our country, but I'm pretty confident that things are going to change. Probably another example is, from what I saw, is well correlation. Let's speak for well correlation as well. It is already automated. By just detecting the similarity between the different sequences, it can be automated automatically. From my side, this is what I saw. If you can add any things you saw, Imad, in PRGM in France.
I think it is also the same thing that I want to say. It's basically to interpret large amounts of data. This is maybe the most forward example that can we give about how AI could advance things in geosciences.
Yeah.
Or other techniques, if I just add something, other techniques are just being developed because we are in the phase of developing algorithms.
Yeah.
Of course, we have only some prototypes. That's why we don't have some concrete results that make something very, very, very practical or very advanced compared to existing tools. But I think in few years we have the results of what we are developing in these years, and of course then we can really make not the decision, but at least have the right we'll be in the right position to make comparison between what we have done and if it is really helpful or not.
Yeah, and to be honest, this is one of the motivations behind this project. This is a new wave. This is something new in geoscience. It's shaking the world of geoscience, and then we don't really want to be behind. Try to bring what we can from this perspective.
Exactly.
Another comments from LinkedIn from Dr. Youssef Bouchachi, who's saying, thank you and for the relevant and promising project. I think that it will help a lot, especially in basin modeling. We thank you, Youssef, and looking forward for another webinar from your side on geomechanics as well. He's an active member in us. We also have other questions from YouTube this time, Salim Alouti. Thank you for the presentation, Imad, and the organizers. If I'm not mistaken, the field of geoscience has been yet somehow lagging behind other disciplines in recent days. And I agree. I agree that we are lagging a lot, especially when you see what's being done in pharmacy, in pharmaceutical studies, biological studies, computer science, imagery, all this are really leading. AI and geoscience, we're still lagging behind. But things are changing rapidly, and we really need to catch up.
We are working on geological time scale, so it is somehow normal for geologists. Thank you, Salim. Salim.
Thank you very much. I think we do have a lot of other questions. A question from Amin again, a question about automatic model interpretation. What criteria do you use to evaluate the quality of the interpretations?
This is very, very, very important question. I think if you speak about what I presented, the criteria are basically confronting what we had made as an interpretation with existing priors. So priors at the beginning, it will be only observations or initial inputs that we have. For example, if you have some or location, or some location of the existing of structures or stratigraphic surfaces. This is the information that will be using to evaluate the next interpretation. And again, if this interpretation is maybe validated, it will be used again as a prior for the next interpretation, and so on, etc., to build progressively the structural model. We can use also other there is some other ways to play with parameters, for example, to weight the parameters basically based on some uncertainty and adding some parameters like this. But the core idea is basically comparing what we have as prior, for sure, and then using other parameters maybe only to enhance or improve the evaluation.
Thank you very much. Another comment from Wise Soul from YouTube. Thank you for the amazing presentation. I wish if you can give us some examples of how we can use AI to create a 3D basin model. Maybe
if I can give you this, I think
I remind that Imad is still, his research is still ongoing. He cannot really show many things.
But it is very ambitious goal to use an AI to build a full 3D model. I think it will be
but probably we can, because I saw some interesting examples. Probably we can invite someone, some experts who's doing something similar in the future. All right. So with that said, I think it's already 1 hour from since we started. I think we covered most of the questions. Everybody is thanking you for the very, very good presentation. Thank you very much again, Imad, for this initiative. I really hope that this is going to kickstart something new, and I hope that we can work together again. INAS, International Network of Algerian Scientists, is open for everyone. I hope that you can join. You can bring some your ideas. We will be very happy to help you and back you up. So with that said, I think we can close the call. Thank you very much, Imad, and looking forward for another.
Thank you again, Mohamed, and Assalamu alaikum, everyone.
Wa alaikum salam. Thank you very much.